Solve the following systems of equations algebraically. Be sure to identify any extraneous solutions. So we'll start with number 7. We've got two linear equations, and I'm going to use the equal values method to solve. So that means that since these two equations are solved for y, I'm going to set them equal to each other. So negative 2/5 x plus 3. Again, I'm setting this equation equal to this one. So negative 2/5 x plus 3 equals 3/5 x minus 2. When we're solving a system, since we have both x and y in our original equations, we want to find both x and y. So I'm going to start by adding 2/5 x to both sides. And typically I would start off here by rewriting this entire equation to get rid of the fractions, but what happens here when I add the 3/5 x and the 2/5 x is that makes one whole x, since we get 5/5 adding those two fractions, so that's kind of nice. We get 3 equals x minus 2. If we add 2 to both sides, that is 5 equals x. So now we just need to find y. Pick either one of these two equations. I'm going to go with the second one and plug in what you've got for x. X was 5. So we've got y equals 3/5 times 5 minus 2. 3/5 times 5 is 3. These 5's kind of cancel out. So y equals 1. And we want to write our solutions for systems as coordinate points. Again, we have both x and y, and these coordinate points represent the points of intersection on the graph. So these two lines would intersect at the point 5, 1. Okay, and that's it for number 7. For number 8, and I know the instructions said be sure to identify any extraneous solutions. You can check 5, 1, plug in 5 for x and 1 for y into both of these two equations, and it'll make the equations true. Okay, for number 8, I'm going to use the same method, the equal values method, to set these two equations equal to each other. Again, since we have y equals, and y is equal to y, then these two equations should be equal to each other. Negative 2x minus 2 squared plus 35 is equal to negative 2x plus 15. Okay, let's simplify the left side. X minus 2 squared is just x minus 2 times x minus 2, which, if we multiply that out, is x squared minus 4x plus 4. We'll bring the rest of this equation down. We still have a negative 2 in front of that parentheses. So we'll distribute this. Negative 2 times x squared is negative 2x squared. And then we've got plus 8x minus 8 plus 35 equals negative 2x plus 15. Let's combine these like terms. Negative 8 plus 35 is 27. And I have this quadratic. I want to get all terms on one side. So we'll add the 2x over to both sides. And then in the same step, we'll subtract 15 from both sides. So what we've got now is negative 2x squared plus 10x plus 14 equals 0. And before we factor this and solve for x, what I'd like to do is factor out a negative 2. I want to factor out a 2 because looking at all of these coefficients, they're all divisible by 2. And -2 specifically, because that would just leave me with the positive x squared term. So if we factor out a -2, okay, -2x squared divided by -2 is just x squared. 10x divided by -2 is -5x. And then positive 14 divided by -2 is -7. Okay, pause for a long time because I'm doing the mental math here and something's wrong, and I realized what it was. This 14 should be 12. Okay, 27 plus -15 is 12, which makes this a 6. Okay, so this is going to work. Sorry for that long pause. No, your video wasn't wonky. It was me. Okay, now I am going to factor this. I'll use a generic rectangle and a diamond to help. -6x plus 5x. Sorry, -6x plus x is -5x, but then multiplied together gives us -6x squared. So when we factor, we get x minus 6 and x plus 1. And now using the zero product property, if I set x minus 6 equal to 0 and x plus 1 equal to 0, we're ignoring that -2 in front of the parentheses here since we cannot set that equal to 0. We get x equals 6 and x equals -1. Again, just like with number 7, since we're dealing with two variables, okay, the original equations had x and y, we still have to find y. So we're going to take either one of the two original equations and plug in x to find y. I'm going to pick this one, y equals -2x plus 15. Plugging in 6 for x gives us +3. And then plugging in -1 gives us 17. So we've got 2 points of intersection here. Okay, x equals 6 and y equals 3 gives us 6, 3. And x equals -1, y equals 17 gives us the point -1, 17.
Great.
So these are my two solutions. You can check your work, plug in x and y, and you're going to see that these solutions are not extraneous. Okay, these are my points of intersection. And that's it for 7 and